In this video, we're going to take a look at the properties of operations. Basically, these are rules that allow us to work out problems, sometimes in a slightly different order. So there's three properties we're going to work on. The first is called the commutative property, the second property is the associative property, and the third property is the identity property. Now all three of these properties will work for addition as well as multiplication. So let's take an example for each one. Okay, let's look at each one. Let's first of all look at the commutative property. The beginning part of commutative begins with the word commute, okay, just without the E on. When you commute, you move from place to place. So a lot of times we'll talk about the morning or the evening commute. Your parents will often commute to work. You'll commute to school. Basically, you move from one place to another. So what that means in terms of properties is it's saying that if I have 1 plus 3, that will be equivalent to 3 plus 1. Now, if I look at both sides, how these problems are different is the 1 and 3 become 3 and 1. Okay? Basically, these flip-flop places. They move from one place to another. Another example, a little bit more complicated. If I do 2 plus 4 plus 1, I could also say that that would be equivalent to 2 plus 1 plus 4. How have things changed? Well, if I take a look at this problem, I notice that this goes 2, then 4, then 1. Over here it goes 2, then 1, then 4. How have the numbers changed from one side to another? The 4 and the 1 have basically switched places. They've commuted, they've moved from place to place. This would be true as even if I had parentheses. In this case, the numbers still have changed places while the parentheses, the grouping symbols, have not changed. This property also holds true for multiplication. So if I look for multiplication, I could say 1 times 3 is going to be equivalent to 3 times 1. Now you'll notice that instead of writing multiplication with an X, like you might be used to, I use the dot. This is one way of writing multiplication. Okay. X often gets confused with variables, particularly as we look forward to algebraic classes or classes in algebra, using the variable x. So more and more we're going to use this little dot to represent multiplication, or we're also going to use parentheses. 1 times 3 is going to equal 3 times 1. Another way of writing multiplication. And I could do the same thing with a little bit more complicated problem as well. I could say 2 times 4 times 3 would be the same thing as 2 times 3 times 4. So basically, with the commutative property, it says that when you have things being added, where it's all addition, or things being multiplied, where it's all multiplication, you can change the placement of those numbers without changing your final value. So over here, 1 plus 3 would equal 4, 3 plus 1 would also equal 4. 2 plus 4 is 6, plus 1 would be 7, where on this side 2 plus 1 is 3, plus 4 is also 7, so 7 would equal 7. Multiplication, 3 times 1, or 1 times 3 is 3, 3 times 1 is 3. Both sides equal 3. 2 times 4 is 8, times 3 is 24. 2 times 3 is 6, times 4 is 24, so 24 is equal to 24, so it's equivalent. So this is the commutative property because the numbers commute, they move from place to place. With the associative property begins with the word associate, if I had an E on the end. Basically, who you associate with means who is in your group. So it deals with grouping. So for this one, I'll deal with 3 numbers. Well, let's take the same problem. 2 plus 4 plus 1. Okay. With the associative property, the numbers themselves won't change places. So you'll notice I have a 2, a 4, and a 1. I have a 2, a 4, and 1. What does change is the grouping symbols. So here, I might put the 4 plus 1 in parentheses, saying you need to do that first, as opposed to over here, where I might group the 2 and the 4 together. The numbers themselves do not change places, but where the parentheses are does. Okay, and the same thing would hold true for the properties of multiplication. If I had 2 times 4 times 3, okay, I would have to have 2 times 4 times 3. But instead of grouping, say, the 4 and 3 together, I might choose to group the 2 and the 4 together. The key part here is the numbers themselves do not change order. Where up here the numbers do change order. Okay? The identity property, if something's an identity, basically you don't change the value of that number. Okay? So this is when you don't change the value of the number. Okay. So the identity property of addition, if I begin with the number 9, what would I have to add to 9 to equal 9 again? Well, I would have to add 0. So the identity property of addition basically says that 0 plus any other number will give you that number itself. So 9 plus 0 would equal 9. When I look towards multiplication, if I do 9, 9 times what would equal 9? Well, in this case, 9 times 1 would equal 9. So the identity property of multiplication deals with multiplying by 1. Where is this used? Okay. One common application with mental math. So, it's meant to make things easier on us. So, for example, if I told you 2 plus 18, no, let's change that. Let's say 2 plus 27 plus 18 equals what? Well, if I sit there trying to do in my head, order of operations, or normally what would happen is I would do 2 plus 27, I would group that first. Well, in this case, 2 plus 27 would be 29. 29 plus 18. Do you really want to do that in your head? I don't think so. Well, let's try and look and say, is there an easier way? Well, what happens if I take 2 plus 18? So if I rewrite this as 2 plus 18 and then add 27, what property am I using? I'm using the commutative property because I'm changing the order. Then I can do 2 plus 18 and I get 20. Well, 20 plus 27 is equal to what? Well, it's equal to 47. So it makes the math a little bit easier. And I can look at the same sort of thing with multiplication, where I might have 4 times 27 times, let's say times 25. Well, if I do 4 times 27, I don't know how to do that off the top of my head. Same thing, and then to multiply by 25, we're getting really hard there. But let's take a look at this. Well, what's 4 times 25 if I rewrite that? And then I multiply by 27 afterwards. 4 times 25 is 100. 100 times 27 will be 27 with the 2 zeros, 2,700. And I was able to do that all in my head. So the key part is you want to look for combinations which will add up to either multiples of 10, that would be easier to add together, or multiply to give you values of 10 or 100 or 1,000 that become very easy to multiply. Hopefully this was helpful. I'm going to have you try 3 problems. Okay. What I would like you to do is to try the problem on pages 6 to 7. I would like you to take a look at number 7, number 17, and number 28. I'd like you to go ahead and try them after watching the videos, and then when we come to class, you're going to have a chance to practice some more. But I'd like you to try these couple on your own, and that way you'll kind of come in and say, yes, I know what I'm doing, or no, where are your questions? Come in with the questions ready to go, ready to ask me, and I'll be working my way around the room to help you, but your classmates may also be able to help you. So looking forward to seeing you tomorrow.